The definition of the product rule says that if we have two functions, f and g, then the derivative of the product of those two functions is going to equal to the function f times the derivative of the function g plus the function g times the derivative of the function f. So in other words, the derivative of the function f times the function g is going to equal to first times derivative second plus second times derivative first. So in the past, we were able to solve problems like y is equal to a constant such as 3 and then a function such as x squared. We're able to take the derivative pretty easily by using the power rule. And when we apply the power rule, the derivative y prime is going to equal to 6x. Here we do have a product of two things. We have 3 times x squared, but the difference is that in these cases we had a constant multiplied by a function. But the definition of the product rule is defined for when we have a function times a function. So in other cases, if we were asked to find the derivative of y is equal to x squared times e to the x, this is an example where we have a function multiplied by a function. So in this case, we would use the product rule. So using the product rule, the derivative y prime is going to equal to first times derivative second. The derivative of e to the x is e to the x plus second e to the x times derivative first. The derivative of x squared is 2x. So here we have the derivative, but it can be simplified a little bit. We notice that we have an e to the x in one term and an e to the x in the other term. So we'll go ahead and factor that out, giving us e to the x times x squared plus 2x. And then we can also factor out 1x, giving us y prime is equal to e to the x times x plus 2. And this is the simplified derivative. So let's look at another example. So here we're asked to differentiate the function f of t is equal to the square root of t times 3 plus 2t. So looking at this, we see that we have a function multiplied by a function, telling us that we're going to be using the product rule. So using the product rule, the derivative f prime of t is going to equal to first square root of t times derivative second. The derivative of 3 plus 2t is just 2. Second, 3 plus 2t times derivative first. Let's see, the derivative of t, we're just going to rewrite that first as being t to the 1/2. And then using the power rule, the derivative will be 1/2 t to the negative 1/2 power, which can be rewritten as 1 over 2 times the square root of t times 1 over 2 times the square root of t. And then we can rewrite this a little bit better. This is equal to 2 times the square root of t plus 3 plus 2t divided by 2 times the square root of t. We're going to go ahead and make a common denominator of 2 root t. So we're going to multiply this term by 2 root t over 2 root t. We can imagine this being over 1. which will give us 4t divided by 2 root t plus 3 plus 2t divided by 2 root t. So now we have a common denominator, so we're going to go ahead and combine those two fractions, which will give us 4t plus 3 plus 2t divided by 2 times the square root of t. And then we can see that we have a common term. We have a 2t and we have a 4t. So we'll combine like terms, giving us 6t plus 3 divided by 2 times the square root of t. And this is the simplified derivative. So what we did is we used the product rule to find the derivative. So this here is the derivative. However, it was kind of messy, so we rewrote it and it became a lot better. So this next one is saying if y is equal to x to the negative 5 halves times e to the x, find y prime. So we see that we have a function times a function. We're going to use the product rule. So its derivative, y prime, is going to equal to first x to the negative 5 halves times derivative second, which is just e to the x, plus second e to the x times derivative first. So x to the negative 5 halves, its derivative using the power rule will give us negative 5 over 2 times x to the negative, we're going to minus 1 from here, so we're going to minus 2 over 2, which will give us negative 7 over 2. So times negative 5 over 2x to the negative 7 over 2. And then we see that we can factor out an e to the x. Doing so, we get e to the x times x to the negative 5 over 2 minus 5 over 2 x to the negative 7 over 2. And then we can go ahead and factor out a negative 7 over 2 because it's the smaller one out of these two x's. So we'll go ahead and do that. So we get e to the x times x to the negative 7 over 2 times, when we factor out a x to the negative 7 halves from x to the negative 5 halves, what we're doing is we're basically adding 7 over 2. And doing that will give us x to the 2 over 2 power, which is just x to the first, which is just x, minus, when we factor out an x to the negative 7 over 2, we just get this coefficient, so we just get 5 over 2. So this is the derivative once we simplified it. Alright, let's look at one more. So say we have y is equal to 4x squared plus 3 times x plus 4. And we want to find the derivative. So looking at this, we do see that we have a function times a function. So we could use the product rule to find the derivative. But if we wanted to, we could avoid using the product rule. But if we want to, we could avoid using the product rule by foiling these two binomials, which will give us a polynomial, and then to take the derivative, we would just have to use the power rule on each term. So we'll go ahead and do that. we're just going to avoid using the product rule and we'll just FOIL these two binomials. So we're not taking the derivative yet, we're just rewriting y. So y is equal to 4x to the third plus 16x squared plus 3x plus 12. So after rewriting this function y, we could take the derivative without using the product rule. We'll just use the power rule. So the derivative y prime is going to equal to the derivative of each individual term. So the derivative of 4x to the third using the power rule will be 12x squared plus 16x squared. The derivative is going to be 32x. And then the derivative of 3x is just going to be 3. And then we have a 12 here. And we know that the derivative of any constant is just 0. So we're not even going to bother writing that down. And that's it. This is the derivative.